To see where the global race for artificial intelligence is actually being fought, you don't look inside a server rack. You look here, a massive, empty plot of farmland in Ohio. For years, the main speed limit on machine learning was manufacturing enough silicon chips, but the industry has hit a new wall. Today, the operational constraint is no longer processing power, it is raw electricity. To push next-generation language models further, companies require immense physical infrastructure. This specific site in Ohio is slated for a mega campus demanding a 10-gigawatt power draw. 10 gigawatts is the equivalent peak energy capacity of a major metropolitan area. To run an AI data center of this size, you would need the constant output of multiple commercial nuclear power stations. Developing these sites has evolved beyond simple office parks or standard warehouse construction. We're seeing sovereign-scale infrastructure projects that require the kind of complex capital stacks usually reserved for national utility grids. The problem with building a 10-gigawatt site is the sheer upfront cost. Traditional commercial bank syndicates simply refuse to absorb tens of billions of dollars in construction risk for a project of this size, unless there are massive credit enhancements to back up the debt. This creates a bottleneck. If developers cannot secure the funds to upgrade high-voltage transmission lines or build dedicated power substations, the deployment of the next generation of server clusters stops before it begins. Nvidia realized its $5.4 trillion market valuation depends entirely on its customers having enough physical power to actually run Nvidia hardware. To prevent a global compute stall, the world's most valuable chip manufacturer had to evolve. They stepped out of their traditional role and became an institutional financial underwriter. The solution took the form of a highly complex, multi-tiered syndicate. Nvidia supplies the heavy capital. SoftBank's infrastructure subsidiary, SB Energy, acts as the physical developer, and OpenAI signs on as the master tenant. Structuring this deal was difficult. Initially, the plan called for Nvidia to provide a $250 billion balance sheet guarantee. Wall Street analysts and internal executives panicked, citing the extreme credit risk of concentrating that much exposure on a single company's ledger. To save the deal, Nvidia restructured the agreement. They scaled the guarantee back to under $120 billion, strictly limiting their backing to the first 5 gigawatts of the project's initial phase. By putting their massive balance sheet on the line, even at this reduced scale, Nvidia provides what commercial lenders call credit enhancement. This backstop dramatically lowers borrowing costs, assuring private banks that their loans will be serviced. Calibrating this risk was exactly what the market required. Nvidia protected its key financial ratios while unlocking the massive institutional debt markets SB Energy required to start pouring concrete. This setup creates what financial analysts call a circular economy within the tech ecosystem. It operates as a tightly integrated 5-stage financial feedback loop. In step 1, Nvidia injects $3 billion in direct equity and over $100 billion in credit guarantees. In step 2, SoftBank's SB Energy uses this capital to physically construct the power generation, specialized liquid cooling systems, and utility hookups in Ohio. Once the shell infrastructure is guaranteed, step 3 activates. OpenAI signs binding multi-decade contracts to occupy the newly built 10-gigawatt capacity. Now that OpenAI has the space and the power, they need the hardware. In step 4, they access a separate $350 billion equipment credit line negotiated with Nvidia to purchase massive quantities of advanced graphics processing units. Finally, step 5, the billions of dollars OpenAI draws from that hardware credit line flows directly back onto Nvidia's income statement as realized revenue. Nvidia is effectively bankrolling its own customers' real estate developments to ensure those customers have the capacity to buy Nvidia hardware for the next decade. By architecting this deal, Nvidia is acting as the central liquidity provider for the entire technological sector. Market analysts have started characterizing them as the Federal Reserve of AI. This strategy of using massive financial scale to lock in major customers extends far beyond the Ohio project. Nvidia maintains extensive strategic equity stakes across the industry, including a massive multi-billion-dollar position in Elon Musk's SpaceX, which recently absorbed the xAI initiative. Meanwhile, the rest of the industry is fighting a very different battle. International competitors are launching models to challenge coding benchmarks, while mobile chip makers are aggressively deploying lower-tier silicon for edge devices and hybrid networks. At the extreme high end of training and model inference, OpenAI and Nvidia are securing a 10-gigawatt utility corridor. By securing 10 gigawatts of utility capacity in a single corridor, OpenAI and Nvidia are claiming a finite resource. It's a land grab that denies competitors the high-voltage access they would need to achieve equivalent scale in the region. The mechanics of the Ohio megacampus show that the future of artificial intelligence dominance now relies as much on complex capital structure engineering as it does on semiconductor design. The primary hurdle for scaling these models has shifted from the laboratory to the power plant. The timeline for the next breakthrough is now tied directly to how quickly utilities can connect new multi-gigawatt loads to the grid. The companies that define the next decade of computing will not just be the ones capable of designing the smartest chips. They will be the ones that command the capital required to conquer the global